Alright, if I have a point here which is 1 pizza and 5,000 burritos, and the utility function looks like this, then the utility level would be U equals 5,000. Is that right? Because the function is the multiple of these two goods. Okay? Think. Now you have only one slice of pizza and 5,000 burritos. And I ask you, if I give you one more slice of pizza without any condition, now your utility level will go up to 10,000, right? And I ask you, what about if I take away 100 burrito from you? Will you feel happier? Yes, you will, right? What about I take away 500 burritos? You will say, yes, I still feel happier than the original one. So how many burritos I take away from you, you will feel the same. The maximum amount of burritos you are willing to sacrifice in exchange of another slice of pizza. If it is 5,000. So if you got 2 slices of pizza and the burritos you need is 2,500, right? So you are willing to sacrifice how many burritos? You are willing to sacrifice 2,500 burritos. Is that clear? What about another slice of pizza? So this time, you're willing to sacrifice. So here, it would be 5,000 divided by 3 is about 116.7. Something like that. Oh no. 167. About 167, right? Am I right? No? Oh, 1,000. Sorry. So this time, the maximum amount you are willing to sacrifice will be, this is 2,500, and this time it will be right. So initially, you are willing to sacrifice this many, and then the willingness to sacrifice decreases because you now got more and more slices of pizza, right? All right. Then, what about MRS? Mathematically, MRS equals MU pizza over MU burrito. And partial differentiate U with respect to Z equals B, and partial differentiate U with respect to B equals Z. Okay? So mathematically, when you are at this point, 1 and 5,000, it will be 1, 5,000 will be negative 5,000. And you see this is a different number from this, right? Because its difference and its differentiation is a tiny change here. It's just a tiny change. Got the point? So if we just make the slope here is actually deeper than the tangent curve, than the tangent slope. The tangent slope is steeper than the second slope. I don't want to make you confused, but this explanation is based on 1 unit, 1 unit, and 1 unit. But for the differentiation, the burrito, the pizza, the change here, when we explain, we give it this term an interpretation, I would say 1 unit. But actually, it's a tiny unit. It's not 1 unit. Okay? Get the point? I just want to tell you the change, because it's a curve, so the change here differs from the change here. But when we make it smaller and smaller, it approaches to the tangent thing, right? Get the point? So this is the interpretation. This is the mathematics we are computing. All right. So when the utility is u of q1 and q2, and we set the functional form as q1 and q2, mu1 equals q2, and mu2 equals q1, and mrs equals minus q2 over q1. This is math. Okay? And if you want a perfect correspondence, I can give you another example here. U equals q1 plus q2. This is another utility function. And it's actually something we have a straight indifference curve. q1, q2. Right? In this case, one more unit in pizza. For example, if this is 1 and 5,000, then this would be 5,001, the utility level, right? And when the pizza, when you got an extra pizza, and what about this level? It's 4,999, right? So that the sum of these two numbers equals 5,001. And what about the marginal utility of good 1? Is 1. Because we partially differentiate u with respect to q1. We got 1. And marginal utility 2, 1. MRS equals negative 1 and 1. equals negative 1. And you see, it's 1, so it's negative 1. It corresponds to each other perfectly because there is no curve, as I said. So it's a straight line, so the differentiation is either in differential or in difference. 微分跟积分 in this case would be the same. Is it clear? Or I may give you some more example here. All right. Be it U equals Q1 times Q2, and it's 50, 50, so it's 2,500, right? What about 51? What's the value here? It would be 2,500 over 51, just a little bit lower than 50. Can anyone compute this for me? What's the number 2,500 over 51? Should be 49 or 48 something. 49.01. So it's 49.01. So it's 1 is 0.99, right? And the slope will be 0.99. It's very close to 1, is that right? And the marginal rate of substitution equals MU1. MU1 means Q2, Q1. At this point, 50-50 would be negative 1. It would be very close in the middle part. But they would be the difference, the result of the difference, 差分的结果, with the result of differentiation will deviate from each other more on the two ends of the curve, but would be quite close in the middle part. Okay? That is a mathematical issue. But since we are using differentiation, we are calculating something very tiny, smaller than 1 unit. Just a tiny change in Q1. We want to know the slope. Okay? And the reason why I just say an extra increase, an extra unit increase of pizza or Q1 is because it's easier to interpret. It's for the convenience of interpretation, to explain to you, to make you understand more easily. Okay? Alright, marginal utility is the extra utility that a consumer gets from consumption, the last unit of a good, holding the consumption of other goods constant. This is the definition of marginal utility. have a curve here, and for any point Q1, Q2. An extra unit holding Q2 the same level. So the utility of these points compared with the utility of these points, if this is one extra unit increase of Q1, then say if this is U0, U1, then U1 minus U0 is actually marginal utility 1 at this point. Okay? So marginal utility means the increase in utility, given or holding Q2, the consumption of Q2, constant. But we may increase just one unit of Q1. And 1 unit is just a conceptual thing. It's a tiny unit. If we increase Q1 a little bit, and we may increase from here to here, or to here, okay? And we'd like to know what about the change in utility. So if we make it smaller, and you'll see the indifference curve will be closer and closer to the original one. But it's too close, you cannot tell. So we just expand to make it bigger so that you may see it. Okay? I just want to make it as large as possible so that you may see it. Otherwise, differentiation should be very, very tiny. The change should be tiny. Okay? Let's proceed to next slide. Different utility functions generate different indifference curve. Alright, we may have this kind of indifference curve. We call that perfect substitutes. Perfect substitute. Translation. Perfect. Perfect substitute. So the utility can be plus Q1 plus Q2. And perfect complement. It will look like this. They are L-shaped curves. And imperfect substitutes. It's a normal one. Just the normal indifference curve just falls between the case of perfect substitute and perfect complements. So case number 1, perfect substitute. Case number 2, perfect complement. And the general cases falls between the first and the second, just right in between. So corresponds to the slide. Case number 1, case number 2, case number 3. Is that clear? And if this is actually the negative 45 degree, it's 1, 1, 2, 2, 3, 3, 4, 4, which means the points 1, 0, 0, 1, 1, 0, 0, 1, their sums equals 1. So the utility level for this indifference curve would be 1. And this would be 2 because this point is 2, 0, 1, 1, 0, 2. Their sum are 2, right? And 3, 0, 2, 1, 1, 2, 0, 3. 4, 0, 3, 1, 2, 2, 1, 3, 0, 4. Okay? So this form is the so-called perfect substitute. And let me give you an example. If you have, say, if now I make Q1 equals the $100 bills, the number of $100 bill, and this may be the coin, the $50 coin. So you know what I'm talking about? The red paper, $100 bill, and 50 coin, the gold, the gold color coin we have in NT dollars. All right. So if I give you 1, you have one $100 bill, paper bill. The utility would be the same as two $50 coins. Two $50 coins, right? Because the sum, the total value of this point would be 100, and the total value of this point would be 100. And in this case, how can you put down the utility function? It will be Q1 plus 2Q2, or 2Q1 plus Q2. Which one is good? Is correct? Should be this one, right? Think about this. All right. 100 Q1 plus 50 Q2 should be more straightforward. Now you have 1 Q1. So the total value of the money you have is $100, right? And if you have no $100 bill, but you have two $50 coins, then the total number or the total value of your money would be $100. And the reason why I say it can be 2Q1 plus Q2 is not an equal sign here. We may put this into this is because we just divide this term by 50. So it's still a positive monotonic transformation, right? So we may have another utility function, U prime, U tilde. And these two utility functions are capturing the same thing. Okay? So the utility function would look like this, straight line, because they are perfect substitute. So it would be indifferent when I pay you money in $100 bills or in $50 coins. Okay? If you only care about the money amount rather than the weight. Okay? But now you see the slope, it will be -2 rather than -1. So it depends on what you are analyzing, what kind of goods you are analyzing. Either this one or this one are actually, both of them are perfect substitute, but the rate of substitution is different. It's -1, it's -2. And the reason why this is -2 is because the marginal rate of substitution, this is the formula, okay? It's mu1, mu2. Now, if we take this as the utility function, what about the mu1? mu1 would be 100, so it would be -100. And what about mu2? mu2 is 50, so it's -2. But if you take this as the utility function, mu1 would be -2, mu2 would be 1, so it's again -2. So this one or this one actually capturing the same thing, same preferences. If you got your preference as the perfect substitute, but the substitution rate is -2, then either in this form or this form will be good. We don't care about the cardinal property, we just care about the ordinal property, okay? Remember that? So we may transform this monotonically to this. Alright, the last example, I'd like to explain perfect complements. If you want to buy shoes, you got right shoes and left shoes, right? If you want to buy a pair of shoes, it consists of one right shoe and one left shoe, right? So, right shoe, left shoe, I should put it here, left shoe. So one left shoe, one right shoe gives you a pair, so pairs of shoes. It will be one. If two left shoes, two right shoes gives you two pairs of shoes. What about two left shoe but one right shoes? Two left shoes and one right shoe. How many pairs of shoes you have? One. There is a useless extra left shoe. You don't need it, right? So this combination would not give you a higher level of satisfaction than this one. You care about the pairs rather than the numbers for each good, right? That is the reason if you have a one right shoe, one left shoe, and this gives you a combination, a pair of shoes. And this one right shoe with two left shoes still give you one pair of shoes.